Hi class, it's Mrs. Kane and I'm here with your next e-learning video. Today I'm going to be starting Unit 8 and the topic is trigonometry. I'll be working through some of these topics over the next couple weeks. It will culminate in an assessment and then it will be on the final exam. So we're going to start by reviewing some of the basic trig functions that you learned in geometry, the sine, cosine, and tangent, and I'm also going to introduce you to 3 new trig functions called the cosecant, the secant, and the cotangent. So when you think of trig, you likely think of the expression SOHCAHTOA. Okay, and SOHCAHTOA is used to help us remember the relationship between sides in a right triangle. And so when we think SOHCAHTOA, the S in that expression stands for the sine of an angle. Okay, and the sine of an angle, which is abbreviated SIN, the sine of an angle is its opposite side over the hypotenuse. And so the reason we write SOHCAHTOA is to remind us that the sine is the opposite over the hypotenuse, the cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. So just kind of teaching this as if you've seen it before, I want to remind you what that SOHCAHTOA means. Okay, so what do we mean by these words opposite, adjacent, and hypotenuse? Okay, well, we're referring to the sides of a triangle given a reference angle. So in this picture here, I want you to think of this here. This is an angle called theta. It's a Greek letter often used in geometry or pre-calculus or calculus to reference the name of an angle. Okay, and if this is our reference angle, then we can use that angle to find the opposite side, the adjacent side, and the hypotenuse. Now, the hypotenuse of a triangle, of a right triangle, never changes. It's always opposite the right angle, and it's always the longest side in the right triangle. So for this particular triangle, the hypotenuse is this side right here. And if this is our reference angle, theta, then the opposite side is the side over here. It's on the opposite side of the triangle from the reference angle. And that leaves us with one more side, which is called the adjacent side. Now, it's important to label the hypotenuse first, because otherwise it can be confusing which side is adjacent and which side is the hypotenuse. Okay, so we have 3 new trig functions that I'm going to introduce you to. So these are called your reciprocal functions. So the reciprocal functions, the reason they're called that is because they are the reciprocals of the big 3, the sine, the cosine, and the tangent. I'm actually going to kind of go backwards when I introduce these. So the cotangent of an angle is the reciprocal of the tangent. Okay, and that one's pretty easy to remember because it's got the word cotangent, has the word tangent in it. So if the tangent is O over A, then the cotangent is A over O. All right, similarly, the secant is the reciprocal of the cosine. So the secant is the hypotenuse over the adjacent side. One way to kind of remember that those go together is if you read the word secant backwards, it looks like cosine. Okay, obviously the E should be an O, but it's kind of an easy way to remember that the secant goes with the cosine. And then the last one is called the cosecant, and that goes with the sine. So if the sine of an angle is the opposite side over the hypotenuse, then the cosecant is the hypotenuse over the opposite side. And so these 3 trig functions are called the reciprocal functions. And so you're going to be asked to find all 6 trig functions given a right triangle. All right, so let's kind of go ahead and take a look at a big example. So we have this triangle ABC, and we're asked to evaluate all 6 trig functions for angle A and angle C. So if you look at your triangle, you'll notice that you're missing one of the sides. And so if we want to find all 6 trig functions, we need to know all 3 sides. And so if I have a right triangle, I can use the Pythagorean theorem to find the 3rd side. So I'm going to call this side x, and I'm going to say x squared plus 4 squared equals 49, 7 squared, which is 49. So x squared plus 16 equals 49. If I subtract 16, I get x squared is 33. And then if I take the square root of both sides, x is the square root of 33. And so this 3rd side is equal to the square root of 33. And what I want you to notice about your questions is that the first 6 questions ask about angle A, and then the next 6 ask about angle C. So it's important to note which angle is the reference angle. So if angle A is my reference angle, okay, the hypotenuse never changes, remember. So the hypotenuse is the side opposite the right angle. It's the longest side. So for this triangle, the hypotenuse is 7. If my reference angle is angle A, then my opposite side is where the 4 is, and my adjacent side is where the 33 is, square root of 33. All right, so I'm going to go ahead and write SOHCAHTOA right here so I can see it. You can also just kind of scroll up so you can remind yourself of the trig ratios. Okay, so the sine of angle A is the opposite side over the hypotenuse. So the opposite side is 4, the hypotenuse is 7, and so the answer is 4 over 7. The cosecant of angle A is its reciprocal, 7/4. The cosine is the adjacent side over the hypotenuse. So this time the adjacent side is the square root of 33. The hypotenuse is still 7. And then the secant looks like cosine backwards. That's the reciprocal of the cosine, so 7 over the square root of 33. And lastly, for the tangent of angle A, we're going to do the opposite side over the adjacent side, which is 4 over the square root of 33. And then the cotangent, we just have to flip that. And so we get the square root of 33 over 4. Okay, so now we're going to switch reference angles. And when I switch my reference angle, I'm not going to change the hypotenuse. The hypotenuse does not change. Okay, but I am going to reverse my opposite side and my adjacent side. And here's why. If I move to angle C, now my opposite side is over here and my adjacent side is right here. Okay, and so now my sine of angle C, sine is opposite over hypotenuse, so I get square root of 33 over 7, and then its reciprocal is 7 over the square root of 33. And then for the cosine of angle C, 4 over 7. And then the reciprocal is 7 over 4. The tangent of angle C, opposite over adjacent, is going to be the square root of 33 over 4. And then if I flip that, I get 4 over the square root of 33. Okay, so make sure you know how to find those 6 trig functions. Okay, so moving on, we are going to learn to use these trig functions to find either missing sides or missing angles. Okay, so on the top of your paper, I want you to go ahead and write SOHCAHTOA, because this is going to help us to find these missing sides and missing angles. And before we get started, I want you to go ahead and turn on your calculators. And I want you to hit the mode button, which is right next to the second button. And I want you to make sure that the word degree is highlighted. And if it's not, go ahead and scroll over to degree, hit enter until it's blinking, and then hit second mode and go back to your home screen. We have to make sure our calculator is in degree mode when we do these problems. Okay, so example 2, it says solve for x, round answers to the nearest tenth if necessary. So when we have a right triangle, we can use trig to find missing sides and missing angles. So notice I cannot use the Pythagorean theorem because I only know one side. But in addition to that one side, I also know one angle. And so I'm going to highlight the angle I know, the side I know, and the side I'm looking for. Okay, and then I'm going to go to my reference angle, and I'm going to label the side relationship with regards to the reference angle. So the x is the hypotenuse of the triangle, the right triangle, and the 31 is the adjacent side. And so I know A and H represents the cosine. So I know that the cosine of 24 degrees equals the adjacent side, which is 31, over x. Okay, and now I can go ahead and I'm actually going to put a 1 underneath the cosine, and I'm going to cross multiply. So I get x times the cosine of 24 equals 31. Okay, so I cross multiplied. And now, to solve for x, I'm going to divide by the cosine of 24. And I get x equals, I'm going to go to my calculator, 31 divided by cosine of 24. And you should get 33.9. And so that missing side length is 33.9. Okay, so if that made sense, go ahead and try the next one. Pause the video. Otherwise, stick with me for another example. So this time I'm going to go ahead and highlight my angle, and then I have the opposite. I'm looking for the opposite side, and I know the hypotenuse. So this time I'm going to use the sine. I know that the sine of 58 degrees equals the opposite side over the hypotenuse, which is 18. And then I'm going to put a 1 here. I'm going to cross multiply. X times 1 is x equals, put the number in front of the trig function, 18 times the sine of 58. And then go to your calculator. 18 times the sine of 58. X equals 15.3. Okay, and so that's how you use trig to find missing side lengths. Now, in addition, we can use trig to find missing angles. The key is that when you are trying to find a missing angle, we use the inverses of our trig functions. Okay, and you might remember from geometry that the notation for the inverse trig functions, you have sine to the -1, cosine to the -1, and tangent to the -1 of the angle. And these inverse functions are just found using your calculator. So you're going to use the second button on your calculator, second sine, second cosine, second tangent. So we're going to set these problems up the same way we did the previous set. I'm going to start with the angle I'm looking for. I'm going to identify the two sides I know. So for this next example, given this reference angle, we're working with the opposite side and the adjacent side. And so if I think of SOHCAHTOA, okay, I'm using the tangent. I know that the tangent of angle X equals the opposite side, which is 30, over the adjacent side, which is 18. Now, I can't solve for X by dividing by tangent, but you can use that second button in your calculator. So when you're trying to find a missing angle, all you're going to do is you're going to say second tan of 30 over 18, and that is going to take you directly to the degree measure, the measure of the angle. Second tan of 30 over 18, and what your calculator does is it finds the measure of the angle whose tangent is equal to 30 over 18. And so we get 59.0 degrees. So the key is write the equation and then just do inverse. It's actually easier than finding a missing side because you don't have to cross multiply. All right, so for the last one, you can go ahead and try it, or you can stick with me. We're looking for this angle. Okay, we have the hypotenuse is 50 and the adjacent side is 30. So A and H, that's going to be the cosine. The cosine of X equals 30 over 50. Okay, if you feel stuck, remember, oh, I'm looking for a missing angle. So all I have to do is second cosine of 30 over 50 in the calculator. And that will take you directly to your answer. Second cosine of 30 over 50. And this angle measure is 53.1 degrees. All right, so hopefully some of that sounds familiar. I know some of you learned it last year, but it's been a long time, and trig is not usually very easy. So thanks for tuning in, and I'll see you guys soon. Or I will post another